Hello and welcome to the Unit 5 Section 5 video on midsegments. So we're going to start by talking about what midsegments are. A midsegment of a triangle is a segment that joins the midpoints of two sides of a triangle. Every triangle has three midsegments which form a midsegment triangle, and you see that here in this figure. If we bisect each of the sides here and connect that bisecting point, we end up with a triangle. And the midsegment triangle happens to be similar to the triangle that it is the midsegment triangle of. Okay, so let's explore this a little bit by taking a look at a midsegment in the coordinate plane. So in this example, we want to show that the midsegment KL is parallel to GJ, and that KL is half of GJ. Okay, so these are things that we're going to try to show. First, we're going to find the coordinates of K and L. Now, there are two ways you can do this. One, you can find the coordinates by using the midpoint formula, which I'm going to demonstrate here. So for K, we know that this is the midpoint of H and G. So we're going to use those points. We take our x's and find the average. So x1 plus x2 over 2. And then you have y1 plus y2 over 2. And that's going to give you negative 6, 2. For L, same thing. We're going to do x1 plus x2, which is negative 5 plus 1 over 2, y1 plus y2 over 2, which is 6 plus 2 over 2, and that's going to give you negative 2, 4. But since we're given the graph, probably the easier option would have been just to find the coordinates on the plane. Negative 6, 2, negative 2, 4. Either way would have worked, but there it is mathematically in case you wanted to see it that way. That goes back to Unit 1 material. All right, step 2, we're going to compare the slopes of KL and GJ. So, how do we compare those slopes? Well, you're going to do y2 minus y1 over x2 minus x1. So the slope of KL is going to be y2 minus y1 over x2 minus x1. So you do that math and you get a slope of 1/2. Then we need to find the slope of GJ so we can compare it. Again, y2 minus y1 over x2 minus x1. And that again is going to be 1/2. So we have the same slope. So since we have the same slopes, since the slopes are the same, then we can say that KL is parallel to GJ. So that was the first thing that we were set out to determine. The other thing that we wanted to find out is KL equal to 1/2 of GJ. We need to show that. So we are going to pull out the distance formula. So I'm going to have to cut this off a little bit. Refer to your notes to see what these points are. Okay. So KL, the length of KL, is going to be negative 2 minus negative 6 squared plus 4 minus 2 squared. And that is going to be equal to 2 square root of 5. We're going to go with exact values here. GJ, this is going to be the square root of 1 minus negative 7 squared plus 2 minus negative 2 squared. And that ends up being 4 square root of 5. So, since 2 square root of 5 is equal to 1/2 of 4 square root of 5, then we can say that KL is 1/2 of GJ. Okay? So, these are relationships that we have discovered through this investigation here. If you don't remember the distance formula, I'll refer you back to Unit 1 to refresh yourself on that. So now let's use the triangle midsegment theorem. Now that we've shown some relationships here in example 1, the triangle's midsegment theorem states that a midsegment of a triangle is parallel to a side of the triangle, and its length is half the length of that side. Okay? So DE is parallel to AC, and DE is half the length of AC. Another way you can look at it is AC is twice the length of DE. That may be easier in some cases to use. So let's look at example 2. We're going to use the figure to find each measure. So first, UW. UW is parallel to ST. So therefore, we can say that UW is equal to 1/2 of ST. And if that's the case, then it's going to be 1/2 of 7.4. So UW is 3.7. That's all there is to it. Now, to find the measure of SVU, we need to know that UW is parallel to ST. And that is important because it allows us to use some transversals. So if UV is our transversal between these two parallel segments, then we can say that this angle is the same as this angle because they are alternate interior angles. So the measure of angle SVU is equal to the measure of angle VUW. And the measure of angle VUW is 41. So therefore, the measure of SVU is also 41 degrees. In example 3, we're going to use this figure. So we want to find JL first. So JL is going to be parallel to PN. We know that PN is 36, so JL is going to be twice the length of PN. So let's write it that way. JL is equal to 2. JL is equal to 2 PN. So JL is therefore 2 times 36, which gives us 72. PM is right here, and it's parallel to LK. So we know that PM is going to be equal to half of LK, LK being the longer of the two. Well, LK is 97, so therefore PM is 48.5. And then finally, the measure of MLK. MLK is here. Well, we know that JL and PN are parallel. JL is parallel to PN. That allows us to create a transversal here. Okay, JL, PN are parallel, so that gives us a transversal that we can work with here. If this is our transversal, and we're looking for MLK, we know that MLK is going to be the same as JMP, because we also know that these two are parallel as well, MP and LK. So what we have is corresponding angles. MLK is equal to J and P. So therefore, the measure of MLK is 102 degrees. So you're starting to see that through all of this, we are coming up with a lot of different relationships when we're talking about triangles. So it's very important to take some time in understanding what these relationships are so that you can work these problems more easily, because it's all about knowing the relationships and what you're given. All right, that wraps it up for this section and for this unit. As we head into the third and final unit on triangles, which is, as our sole focus is on triangles, that'll be unit 6. We're going to be getting more into right triangles and the things that we can find from right triangles. That's coming up in the next unit, and a little preview, we're also going to get a little introduction to trig in the next unit as well.